Alright, when we're not done yet. So question IV of question 4. Explain why the corresponding Hall triple for total correctness is not valid by giving a counterexample that shows the triple doesn't hold. So when do these things hold? These things hold if P, then S terminates, and Q. And since P is true, true implies something. Basically, that's only true if this part's true. So this guarantees the code terminates and Q holds. So it seems like a good way to make this screw up, because we know Q holds because we did the partial correctness proof. If in total correctness, if I can cause an infinite loop, that would be enough, right? So looking at the code, can I somehow cause an infinite loop here? Yeah, it looks like if n is 0, right? Then r is r take 0, r is r take 0, r is r take 0. That won't change r. R will never get smaller. This condition will never not be satisfied. So I guess if we just choose n to be 0, and what's the thing we're going to try dividing? I guess something bigger than 0. So we choose x to be, I don't know, x to be like 60. There we go. Then, so r is 60, q is 0. While 60 is bigger than 0, 60 is 60 takes 0, 60 is 60 takes 0, 66 takes 0. Yeah, the infinite loop, right? So then this following code, r is greater than n, r is assigned to be r take n, q is assigned to be q plus 1, never halts. Therefore, it's invalid, because total correctness requires the code must hold. You can never have infinite loops. Alright, cool. Next question. Identify a precondition P such that the Hall triple is valid. Okay, this is an easy 4 marks if you're thinking real clever, right? These Hall triples are valid if P implies S terminates and Q. So a really slick, sneaky solution is just slam in P equals false, right? Choose P equals false. And then since false implies anything, P implies S terminates and Q is true. Cool, done. That felt too easy. I feel like a more honest, more genuine answer in the spirit of the question is like the strongest possible precondition, right? I'm sorry, the weakest possible precondition, because false is the strongest statement there is. False is so strong that it like never holds, right? So we want the weakest precondition, which I guess would be, well, if n is 0, it screws up infinite loop. If n is negative, then r gets bigger, screw up infinite loop. So I guess a genuine answer to this question would be n is strictly greater than 0, right? And then explain what the Hall triple now holds. Well, r assigned to be r take n ensures r gets smaller each loop. Hence, r is greater than or equal to n eventually is false, and the while loop stops. Now, but as written, this is a totally valid solution, and we have to give you the 4 marks, even though it's kind of a cop-out answer, right? It's technically correct, so that's 4 marks right there.